So on this slide, we talk about the formal viewpoint or the axioms of homology. So in particular, we are going to talk about reduced homology theory. So what are the axioms of reduced homology theory? So that is the subject matter of this slide. So start with the CW complex X. So to this CW complex, we can now assign a sequence of abelian groups. So see, we have a large number of abelian groups which can be assigned to this space X, from 1, 2, 3 and so on. So you have assigned a sequence of abelian groups. Now given a map between two CW complexes, say a map F from X to Y, so both X and Y are CW complexes, so this will induce a sequence of homomorphisms between these abelian groups. Now a special property is that these homomorphisms satisfy certain relationships. So first, a map F between CW complexes X and Y induces homomorphisms between the homology groups, and these homomorphisms satisfy the following two conditions. So Fg is the map between two spaces, and then there will be obviously sequence of homomorphisms between these two spaces. We have already seen these conditions before, so here we are just recapping everything. And the following three axioms are satisfied for the theory to be a reduced homology theory. So the first one is, if two maps F and G are homotopic, then they induce the same homomorphism. So they induce the same homomorphism between the associated abelian groups. So number two is that there are, for the given pairs, there are long exact sequences. So these long exact sequences arise for any given good pair like X comma A. So this is a CW pair. Obviously we are talking about CW complexes, so X comma A is a CW pair. So you know I is the natural inclusion map, A is included in X, and Q is the quotient map from X to X by A. So standard long exact sequence is induced. So let me write this down, where I is the inclusion map and Q is the quotient map. So now we should talk about the naturality condition. So this is also part of axiom number 2. So obviously we have talked about the long exact sequence. We should also talk about relationship between long exact sequences, which could be induced by a map F between good pairs. So consider this map F. Yeah, this goes from pair XA to YB. Yeah, this automatically induces a quotient map, say F bar. So the naturality condition or the naturality axiom tells us that the following diagram would be commutative. So basically you have precisely the naturality condition we have described before between these two spaces. Here, so I'm going to draw one of the squares. So this is the map which is induced. This is F star and this is F bar star because it's the quotient map. So number 3 concerns the wedge sums. So consider a space X which is made up of wedge sums. Yeah. So this X is equivalent to or equal to this is made up of like this bouquet of spaces. And we have inclusion map. Yeah, each of these X alphas lie in X. So what we get is these inclusions induce a direct sum map, and this direct sum map is an isomorphism. So let us write this down. So an important remark is that this alpha could be infinite. Also notice that or note that the value n could be negative. That is, the subscripts n here could be negative. And this is given on page 160 of Hatcher. It's called section 2.3 formal viewpoint.